So we're on lesson 202. Biggest part of that is reading chapter 3 out of the electrical systems book. And they're going to kind of review dwelling circuit, dwelling service calculations. You can see there's a whole bunch of different objectives here. Again, I think, and I hope all these are reviews from year one. We're going to try to gloss over some of this stuff just to remind you guys. So we can see here again more of the objective. You guys can read through that. So right off the bat, they want to kind of remind us general lighting load is calculated by figuring 3 volt amps per square foot of essentially living area. So we're not counting unfinished spaces. We're not counting porches, things like that, but living area, 3 volt amps per square foot. And next we get to the small appliance load. Remember, we need a minimum of 2. In this particular instance, they have 3, but regardless, we need to calculate those at 1500 volt amps for each circuit. Small appliance branch circuit meaning your kitchen counter circuits, right? Here we get the laundry, same thing, 1500 volt amps per laundry circuit where you need a minimum of 1, and usually that's all you're going to have. I want us to find the demand factor for the general lighting load. So everything we just talked about is the general lighting load. So what they do first, if you remember, is they want us to take the first 3000 volt amps at 100%, right? Then anything above that, anything from 3001 to 120,000 volt amps, we're actually only going to take 35% of that value. So that's what we see them doing down here to come to basically a total demand factor lighting load. And that's kind of a big step. Again, I don't mean to gloss over it, but it is a review from last year for sure. Then if we have 4 or more fixed appliances, we're going to basically add up all of our fixed appliances, the stuff we know we're going to have: dishwasher, disposer, compactor, water heater. They have an attic fan. This is going to be different for every house. But essentially, they tell us here basically calculated at 75% of the total load for if we have 4 or more. And you almost always do, but again, that's for demand factor reasons. Now we get into the dryer, closed dryer. If you recall, again, 220.54 is our table for that. Again, should sound familiar from last year. I don't want to spend a lot of time there. Next one, the household ranges. That's a pretty big topic, honestly. And again, this could be a video in itself. And in fact, in year one, I'm sure your instructor spent plenty of time on that. You got to recall 220.55 is our table for that. Remember, we have column A, B, and C on that table, basically A being the smallest, and then going up to C being the largest. Refresh your memory on that table. That's a complicated section. And again, the next couple slides you're going to see here relate to that. Again, that could be its own video in itself here. It should sound familiar from last year for sure. Right. Again, they're giving us 4 or 5 slides on the ranges there. The largest of the heating or AC load is the next piece they want us to throw in. Remember, we call that non-coincidental loads, something that's not going to run at the same time. Heating and air conditioning, we only need to talk about the biggest one. We only need to account for that in our service size. Now we're adding basically 25% of our largest motor load, essentially because 220.50 tells us we have to take motor loads at 125%. Whether you want to think of it as a continuous load, whatever the case, we only have to do that for the one largest motor. We don't have to do that for every single motor load in our building. Demand factors are applied to the neutral load. Frankly, I don't spend a ton of time, and I don't want you guys to dedicate a ton of time, because rarely at this point are we reducing neutrals. And usually if it's residential, you're pulling a cable anyway. So you're going to have the neutral that is sized per what is in that cable. But we are permitted to reduce conductor sizes for service feeder rating from 100 to 400 amps. This is kind of a often overlooked code, but 310.15b7 permits this. If you think about it, we can use a 4-aught aluminum is commonly used for a 200 amp service. If you check 310.15b16, that's not quite going to cut it, but 310.15b7 actually permits us to do that. They permit, and I think the factor is 83% here across the board. But you can see that's why we get away with those slightly smaller sizes residentially. And then once more, they're going to remind us here, we are permitted to reduce grounded conductor by 70%. There again, that's not something we see very often. Again, if you're doing a service entrance cable install, that's not really a factor or an option regardless. So again, I know we just breezed through a lot of information, but it should be a refresher from year one. What I'll do, I'm going to post a link to, if you guys recall, in the EWR book, there's actually a really nice a guide, a sheet that kind of lets you sort of fill in all the blanks. I'm going to post a link so you guys can download that. Again, you do have that if you still have your EWR book. It's in the back of that book as well. But I think that really does a nice job making sense of all this, laying it out in a way you guys can understand. So again, I'll post some links on the LMS to help you guys kind of visualize this and give you a refresher. But read through it. If particularly with the range calculation stuff doesn't make sense, reach out. But it's a big topic and a lot to think about.